Hi, I'm Sandra Bay from the Atlas Institute at CU Boulder, and today I'll be presenting Making Data Tangible, a cross-disciplinary design space for data physicalizations. Data physicalizations are physical representations of data, but viewing them only by this definition is rather a limiting view. Each physicalization artifact is also a product of the different research communities that physicalization is a part of, and of their perspective and values. Where, for example, some have an analytical aim, seeing how physicality can assist in data-driven tasks. Others focus on creating new interactive systems to interact with data. Or they investigate the essential qualities and how objects can promote and solve social cultural problems. As a result, physicalizations are diverse in their data expressivity, such as data encoding and data interactions, structural considerations, and even the context they appear in. This diversity reflects how data physicalization sits at the crossroads of various domains, yet the field currently lacks a cohesive lens. Consequently, designers and researchers may be unaware of the knowledges and practices emerging in other communities, such as data visualization, which investigates on how to effectively encode data, tangible user interfaces, which focuses on how to amplify the capabilities of the human body and the physical world for interaction design, or design, which focuses on identifying and leveraging a material's potential. Thus, how can physicalization researchers and designers have a cohesive lens of each intellectual community? To address this question, through a systematic review, we present a design space that highlights the cross-disciplinary considerations when creating physicalizations by synthesizing knowledge from the three relevant HCI communities. To elaborate more on our methodology, we use a systematic keyword search using two databases, and filter papers through our inclusion criteria to arrive at a final corpus of 47 papers. For more details, please refer to the paper. From the final corpus, we analyze these 47 physicalizations, where we derive 13 design dimensions housed under three facets. Context, which aims to understand the physical, social, analytical frames a physicalization is addressing in addition to its end-user consideration. Interactions, to understand the dialogue between the user and the physicalization. And lastly, structure, to understand how data is physically embodied and encoded, including its overall form and materiality. Our design space revealed insights about these 5 questions. However, for the sake of time, I'll be only discussing 2 out of the 5 insights in depth, as these highlight the multidisciplinary considerations. First, question 3. Materiality is the quality of presence in the world, and it is a critical dimension for physical artifacts. It not only influences how the artifacts physically takes up space, but how users will perceive and interact with them. And in this paper, we offer our perspective on the 3 different qualities that contribute to a physicalization's materiality: its embodiment, how data is physically manifested, its use of materials, and how long data is shown. One struggle we faced when discussing about a physicalization's materiality was our lack of vocabulary. How could we compare and discuss 2 seemingly different artifacts? Where, for example, Making Data Matter presents a multi-material print of brain scans, and listening cups are 3D printed ceramic cups embedding data of everyday ambient noise. To provide this vocabulary, this requires first discussing of the designer's intent of how the data is embodied, whether it was technologically or contextually driven. Technologically driven physicalizations focuses on how the presented technology encodes data, which includes making data matter through the use of voxel printing. Other platforms within this category include shape-changing displays, sonar robotics, among others. In contrast, physicalization whose embodiment was contextually driven did not emphasize the presented technology, but rather heavily relied on its environment, activity, or the individual themselves to shed insight on the encoded data, such as listening cups. The embodiment of a physicalization also revealed its use of materials, which is the second dimension of a physicalization's materiality, and how researchers leverage materials with respect to data. Physicalizations using electronic components such as emerge and polysurface generally supported multiple datasets for new lines of inquiry and analysis through their computational capabilities. In contrast, physicalizations made from non-electronic materials such as Huron and the forgetting scarf typically targeted a single data set and focused more so on reflection of the data set during the hand-making process. The third and last dimension is data duration. Data duration influences whether individuals are able to interact with data anywhere at any time they desire, or whether it's only available in the moment, such as torrent, whose data is ephemeral. In contrast, physicalization whose data persist offer users some control over how long data is displayed. Venus material uses microfluidics to represent a dynamic line chart. By directly pressing on a liquid chamber, the user can control the flow of liquid with their finger. Lastly, physicalizations that display their data permanently embeds or integrates data into its physical structure, such as conventional 3D printed objects. To understand what interactions a physicalization affords, we examine interactions using two lenses. First, we use Yi et al.'s framework to identify the different data interactions imposed on the physicalization by the user. As our second lens, we examine how interactions occur at the artifact level, how it invites people to conduct a particular data interaction, which is perceived affordances, how it will inform what the result of the performed data interaction will be, which is feed forward, and lastly, how it will communicate the result of their action, which is feedback. Using these two frameworks, we analyze to see how physicalizations accomplish data interactions. And of all the interaction techniques, explore, which is to interrogate different subset of the data, was the most pervasive, and it was accomplished in one of two ways. Direct interaction stimulated the user's sensory affordances by primarily appealing to the perceptual motor skills, such as inviting individuals to pick up discrete pieces like shapebots and modis, or offer visual cues as to what the physicalization might feel like listening cups. In contrast, indirect interactions presented a different interaction scheme by presenting physical controls that people are more familiar with, such as buttons, sliders, and knobs. As a quick recap, we briefly covered 2 out of the 5 insights our design space covers. Please refer to our paper to learn more about the other 3. Now I'll be discussing how we envision others to use our design space. The primary motivation of the design space is to bridge knowledge from the visualization, TUI, and design communities. This need is pertinent as our conducted survey shows that data physicalization researchers not only come from various backgrounds, but also seldom draw on their literature and techniques from other communities. Thus, using our design space, we envision researchers to cross-pollinate knowledge. For example, researchers from the design and TUI community can consider data interactions beyond explore. But the visualization literature shows that these interactions must be considerate of identifying the user's tasks, which many of the physicalizations did not explicitly state. Vice versa, those from the visualization community can consider how to enrich physicalizations by considering materiality and tangible interaction techniques from the TUI and design communities. In summary, through a systematic review, this work presents a design space that synthesizes knowledge from across the visualization, TUI, and design communities, and it provides a cohesive overview of what designers should consider when creating a physicalization. With that, I'd like to thank all of my co-authors on this paper, and please feel free to reach out with any questions you may have. And check out our project page and website gallery. Thank you.